Imagine yourself confined within a colossal metal vessel, weighing several tons, propelled by ferocious bursts of nuclear fire as it hurtles through the eternal darkness at a staggering speed of 60,000 kilometers per hour. Or even faster. At such terrifying velocities, even a minuscule speck of dust, no larger than the tip of a needle, could transform into a devastating projectile, capable of piercing the hull and abruptly ending your mission in an instant. We often shudder at the thought of asteroid belts, those cosmic reefs that science fiction films depict as deadly labyrinths, where spacecraft must weave and dodge with acrobatic precision to survive. But allow me, your companion on this intellectual voyage, to unveil a truth that is both astonishing and tinged with the irony of creation. The vast expanse of space is predominantly a realm of profound emptiness, where collisions are the true marvel, and safety emerges as the natural order. When we contemplate the solar system, our minds tend to conjure images of a bustling playground, teeming with planets, moons, and asteroids jostling like vehicles in rush-hour traffic. Yet, reality paints a starkly different picture. Let us embark on this journey from our beloved home, Earth, where your spacecraft ignites its thrusters to achieve escape velocity, surpassing 42 kilometers per second to break free from the Sun's gravitational embrace and venture into the void between Mars and Jupiter. This is the domain of the renowned asteroid belt, a zone that, in the popular imagination, resembles a dense minefield littered with millions of lurking rocks poised for catastrophic impact. Indeed, astronomers estimate there are over 1 million known asteroids in this main belt, with projections suggesting between 1.1 and 1.9 million larger than 1 kilometer in diameter, alongside countless ancient fragments from the dawn of the cosmos. However, do not succumb to alarm, for the density described by astronomers bears little resemblance to the crowded scenes of everyday life. This belt sprawls across an immense cosmic canvas, with a width spanning hundreds of millions of kilometers and a circumference encircling the Sun for billions more. Envision yourself adrift in a pitch-black ocean, where the nearest object, even a modest boulder, lies millions of kilometers away, farther than multiple times the distance from Earth to the Moon. If you were to perch upon any asteroid in this belt and gaze outward, your view would encompass nothing but an abyssal night sky punctuated by distant stars, devoid of the dramatic flybys of looming rocks portrayed in cinema. Even Ceres, the belt's largest body with a diameter of approximately 940 kilometers, stands as a solitary mote in this vast cosmic desert. Statistics reveal that 90% of these objects measure less than 1 kilometer across, with average separations between asteroids reaching millions of kilometers, comparable to the span from Earth to Mars. It is this chilling sparsity that renders the probability of a spacecraft inadvertently colliding with an asteroid vanishingly small, less than 1 in a billion. To grasp this, consider that such an event is rarer than winning the lottery jackpot hundreds of times in succession. Consequently, the concerns of engineers at the National Aeronautics and Space Administration or other space agencies have never centered on dodging rocks, but rather on meticulously calculating trajectories that harness planetary gravity assists to conserve precious fuel. Probes like Voyager and New Horizons have traversed this belt without the need for elaborate evasion systems, akin to launching an arrow blindly into an endless sky. Yet, the narrative of emptiness merely begins here, intensifying as we venture farther, beyond Neptune's orbit into the frigid frontiers of the solar system. Enveloping us lies the Oort Cloud, a colossal spherical shell harboring trillions of icy comets, relics from the system's formative era. This region boasts a diameter potentially reaching 2 light-years, or about 19 trillion kilometers, with estimates suggesting it extends from roughly 2,000 to 5,000 astronomical units inward to as far as 100,000 astronomical units or more from the Sun. The mention of trillions of comets might evoke a shiver. But recall that the Oort Cloud's volume defies human comprehension. Matter here is so diffuse that the average distance between comets can exceed 1 billion kilometers. Akin to the gulf from Earth to Saturn, colliding with a comet in this expanse would be as improbable as hurling a pebble from Hanoi and striking a drifting dust mote in Ho Chi Minh City. Before reaching the Oort Cloud, however, Our vessel must cross another enigmatic domain, the Kuiper Belt. A donut-shaped disk of icy bodies beyond Neptune. Home to dwarf planets like Pluto, Eris, Haumea, and Makemake. This belt, extending from about 30 to 50 astronomical units, serves as the source of short-period comets and contains objects that, like those in the asteroid belt, are sparsely distributed across vast distances. Recent missions, such as New Horizons' flyby of Arrokoth in 2019, have revealed these worlds as pristine time capsules, offering glimpses into the solar system's infancy without the peril of dense hazards. As our spacecraft truly departs the Sun's protective bubble, the heliosphere, and plunges into the interstellar medium, where the dominion of starless voids reigns supreme, isolation ascends to its zenith. The Andromeda Galaxy, our nearest large neighbor, resides over 2 million light-years away. To fathom this scale, shrink our Sun, a blazing orb of immense proportions, to the size of a tennis ball and place it at midfield in a stadium. In this analogy, Proxima Centauri, the closest star, would not lie at the goal line or in the stands, but as a tiny speck thousands of kilometers distant. Scaled thus, the Milky Way, with its hundreds of billions of stars, resembles a sparse scattering of fine sand across a continent. In the interstellar expanse, matter density plummets to extremes, with each cubic meter harboring merely a few hydrogen atoms, creating a near-perfect vacuum unattainable in earthly laboratories. Thus, mathematical improbability renders collisions with celestial bodies during interstellar journeys virtually impossible. Unless your craft is programmed for deliberate rendezvous or fate decrees an extraordinary misfortune, you would drift eternally in profound silence, untouched by anything. Space is not the cramped, collision-prone peril of fiction. Its threats lurk in radiation, extreme temperatures, and absolute solitude. The universe's expanse diminishes fears of impacts to insignificance, embodying a beauty in stillness, a wordless symphony of nothingness, where distance composes the dominant melody. If your mind feels expanded alongside the cosmic frontiers, yearning for more whispers from the stars where earthly laws shatter, join me in forthcoming explorations of knowledge. The most compelling evidence of this grand solitude comes from humanity's silent emissaries, the twin Voyager probes. Launched in 1977, these vessels have wandered the cosmos for nearly half a century, navigating the asteroid belt, skimming Jupiter's colossal gas storms, threading Saturn's icy rings, and now venturing into the chill of interstellar space. As of 2026, Voyager 1 has traveled approximately 25.6 billion kilometers from Earth, nearing the milestone of 1 light-day distance by November, where signals take a full day to traverse round trip. Throughout their odyssey spanning tens of billions of kilometers, Voyager's computers have never triggered an emergency alert for impending collision with a large rock. In truth, space's real peril stems not from cinematic boulders, but from far tinier foes, micrometeoroids, or cosmic dust grains, at velocities of 17 kilometers per second, dozens of times faster than a rifle bullet. Even a sand-sized particle packs enormous kinetic energy, sufficient to shred metal hulls and devastate sensitive electronics. Hence, engineers at the National Aeronautics and Space Administration equip spacecraft not with barriers against titanic rocks, but with intelligent defenses like the Whipple shield. This design features a thin outer metal layer spaced from the main hull. Upon impact at hypervelocity, the particle shatters and vaporizes into a plasma cloud, dispersing its energy across a broad area before reaching the primary structure. This illustrates that in the cosmos, the most formidable adversaries are often not lumbering giants, but invisible assassins lurking in the shadows. Yet, peering further into a future where humanity aspires to conquer stars at speeds nearing light's limit, the universe's emptiness morphs into a vexing paradox. Traveling at 20% of light speed, those sparse hydrogen atoms, once harmless, morph into a lethal radiation barrage, pummeling the craft like high-energy cosmic rays. The once benign void transmutes into an invisible wall, generating immense drag and heat that incinerates any challenger to nature's velocity bounds. Nevertheless, this remains a tale of distant tomorrows. Today, Astronauts and astronomers alike are enveloped in awe before the unimaginable scale of the darkness. Close your eyes and listen. Space is not the silent tomb you imagine. It hums with eerie symphonies. Transmuted from electromagnetic waves of planets and solar winds, Jupiter's magnetic field howling like a banshee. Or the ghostly whine of interstellar plasma captured by Voyager 1 as it breached the heliosphere. These resonances echo through the void like calls from ancient deities, reminding us that despite human hubris, we are mere toddlers toddling along the shore of an infinite ocean. Each spacecraft we launch is not a conquest of the cosmos, but a hopeful love letter dispatched into the abyss, carrying fragile faith that amid trillions of distant stars, something or someone listens. The universe's emptiness, safe yet barren, is both a boon facilitating our travels and a curse of ultimate isolation. Where gaps between civilizations may prove eternally unbridgeable, in this haunting stillness, the splendor of knowledge and human courage shines brightest, a lone lighthouse illuminating creation's eternal night. When we set aside arid statistics to truly step into a spacecraft's cockpit, the adventure ignites anew. Picture yourself strapped into humanity's most exquisite machine, engines roaring with seismic vibrations, thrusting you at speeds exceeding 60,000 kilometers per hour, dozens of times a bullet's pace, into the inky unknown with audacious pride. Influenced by dramatic science fiction reels, most envision the solar system as a chaotic, confined arena. We picture the asteroid belt between Mars and Jupiter as a gargantuan minefield, where millions of cosmic boulders clash and await to pulverize intruders. With over 1 million catalogued asteroids and likely millions more ancient shards, this dread seems justified. One might assume traversing it demands virtuoso piloting, swerving madly to evade lethal strikes. Alas, the universe's truth is mundanely astonishing, and this banality harbors a majestic beauty in its vast emptiness. Upon attaining escape velocity from the sun's grasp, over 43 km per second, and entering this purported hazard zone, your viewport reveals only absolute blackness. No whizzing rocks, no fiery clashes. The asteroid belt unfurls across a stupendous realm, 200 million kilometers wide, greater than Earth-Sun separation. In this obsidian wasteland, matter's density defies belief. Save for Behemoth Ceres, nearing 1,000 kilometers in girth. 90% of bodies are diminutive specks in the grand vista. Astronomers compute average asteroid separations at millions of kilometers, like dropping 2 sand grains into a colossal stadium, one at each goalpost. Your craft's chance of striking an asteroid here dips below 1 in a billion, rarer than consecutive lottery triumphs. Thus, space engineers fret not over rock dodges, but over astute orbital computations leveraging gravity's subtlety to sip fuel sparingly. But this is merely our backyard. As the ship surges onward, leaving gas giants behind, it enters a colder, more arcane border, the Oort Cloud. This haven shelters trillions of comets, spectral icy wraiths encasing the solar system. Its diameter terrifies, requiring light 2 years to cross. The trillions might chill you. Yet this cloud envelops a volume like a titanic sphere swaddling the system. Density here rivals the finest artificial vacuums humanity crafts. Comet separations average over 1 billion kilometers, Earth to Saturn span. Impact here mirrors flinging a pebble skyward, hoping to nail a mosquito on another continent. Then, as the ship rends the solar system's final veil into star-spanning space, emptiness unveils its fearsome essence. Andromeda, our closest galactic kin, looms over 2 million light-years distant. Miniaturize our sun to a sand grain, the nearest star becomes another grain kilometers away. Thus scaled, the glittering Milky Way with billions of stars mimics sparse dust in a vast dim chamber. Statistically, celestial collisions in interstellar realms verge on impossibility. Barring cosmic malediction, odds approach zero. Space shuns the crowded peril of films, it magnifies physical dangers to insignificance. Overshadowed by eternal solitude. Yet, this is a far future saga. Presently, astronauts and astronomers bask in reverence before the inconceivable nocturnal expanse. Close your eyes and heed, space defies silence. Harboring bizarre tones from planetary electromagnetic waves and solar gales, Jupiter's field screeching. Interstellar plasma's spectral buzz recorded by Voyager 1 beyond the heliosphere. These echoes reverberate the void like ancient gods' summons, underscoring that despite pride, we are infants stumbling seaside an endless sea. Each launched probe is no conquest, but a hopeful missive into nothingness, trusting faintly that amid trillions of remote stars, something heeds. The void's barren safety blesses easy voyages yet curses absolute isolation, where civilization chasms may eternally endure. In this eerie quiet, knowledge's beauty and human valor gleam most vividly, a singular beacon piercing creation's perpetual night. In closing, I extend profound gratitude to the scientists, aerospace engineers, and astronomers, those who devote lifetimes gazing skyward, unraveling cosmic enigmas. Thank you for ceaseless dreaming, calculating, and venturing into the unknown, enabling humanity, from humble beings on a modest blue planet, to comprehend our place amid time and space's boundless flow. Your silent dedication torches the path for human knowledge onward.